The next four icons form the Viewport shading group and are a mutually exclusive set of options which determine how our scene is to be viewed. The first of these display mode options is wireframe, which shows only the edges that make up every mesh in our scene. Unlike the wireframe mode we saw in the previous video, here the faces are omitted and only the edges are visible. An associated set of options is given in a panel created by clicking on the end icon. The contents of the panel changes depending on which of the four display modes is currently selected. In wireframe, the first set of options, listed under the heading, Wire Color, set the color of the edges in our wireframe. Theme assigns a single color based on the Blender theme colors to all meshes. The theme is selected in the splash screen that appears when Blender is used for the first time. Object displays the wireframe of each object with the color it has been assigned within the Object Properties page of the Properties Editor. The color is set in the area headed Viewport Display, in the field labeled Color. We'll be covering this and other options on that page in a later video. Random assigns a different random color to each mesh's wireframe. The next heading in this panel is Background. This specifies settings for the 3D viewport's background color. There are three options. Theme shows the background color defined by the selected theme. World shows the background color set up on the World page of the Properties Editor under the title Viewport Display, Color. Viewport sets the background color to that chosen in the color bar that appears immediately below when this option is selected. The final heading in this panel is Options. Under this heading we have an X-ray option. When the associated checkbox is selected, we can adjust the accompanying value to set the level of visibility of edges which would normally be hidden when viewed from our current position. Lower values make these edges more visible. Outline allows us to choose a color for the edges on the border of all the meshes. The border being the outermost edges from our current viewpoint. So if we change viewpoint, the edges which constitute the border change. The second icon in the Viewport shading group is Solid. This shows only the faces of the meshes when working in object mode. This is the default shading used at the start of any new project. The panel produced by the end icon contains some of the same options as before, but most are new. Our first heading, Lighting, offers three classes of lighting and surface color which can be applied to our scene. These effects have nothing to do with any lights or textures we may have applied to in our scene and are purely there to help us visualize the shape of our meshes. They will have no effect on the final rendered image. Studio gives a choice of lighting effects which is determined by clicking on the sphere beneath. This produces 6 spheres, each with slightly different shading and lighting. Clicking on one of these will change our scene to match its characteristics. Beneath the sphere is a rotation option, and this can be used to adjust the angle of the light source, thereby changing the shading on our objects. The globe icon to the left of rotation is on by default. This means that the shading created by the studio lighting does not change as we move position. If we switch this option off by clicking on the globe, the shading moves as we change viewpoint. This can be clearly seen on the monkey head. Matte Cap, which is short for Material Captures, uses the same approach as Studio, but this time we have a wider range of lighting and colors. We just need to click on the option we want to see in the viewport. Notice that the matte cap color is combined with any other color defined elsewhere. Although we cannot rotate a matte cap lighting in the same way as Studio lighting, we can mirror the effect by clicking on the arrowed line on the side. Flat ignores lighting and just shows objects as a solid color. Wire color has the same purpose and options as we saw in the wireframe display option. In fact, any value set there previously will be carried over to the solid display option. Initially, this may seem like a pointless option since solid display does not show edges, not in object mode. But if we recall, there is a wireframe option in the Viewport Overlays panel, and if we switch that option on, the edges become visible and will be displayed in the color determined by the wire color setting. The color heading gives us no less than 6 different ways of determining the mesh face's color within the 3D viewport. Most of these are set up in various pages of the Properties Editor. But, again, we need to be aware that none of these colors reflect what will appear in the final render. When we select Material, the objects show the color specified in the Properties Editor's Materials page under the heading Viewport Display, Color. As the name suggests, it is a color for the display only. We'll be talking more about the Materials page in the Properties Editor in a later video. Object displays the color defined in yet another page of the Properties Editor. This time it's on the Object Properties page, and again it's under the heading Viewport Display, Color. Attribute displays a color defined within the Object Data page's color attributes. If no color has been defined here, then any color set up in the Object Properties page's Viewport Display, Color is displayed. Single shows all the objects in the same color, which can be selected in the color bar below. Random displays each object in different, randomly selected muted colors. Texture will display any texture image assigned to an object if one has been created in the Material page. In addition, the Object Properties page must have its Viewport Display As, set to Textured. As we can see, the color settings can be quite complicated, but in reality, it's an option we are unlikely to need often, since matcap is usually enough when we want to add artificial coloring to an object. Background has already been covered in the last display icon we looked at. Backface culling, when selected, removes any faces whose back face is visible in our view. In our scene, we can see that this causes the inner part of the torus to be hidden. X-ray, as we've seen before, is best used in edit mode and allows us to see vertices and edges that would normally be hidden from our current viewpoint. But the associated value is a little different from before, since this time it affects the transparency of the object's surface. Shadow checkbox can be used to create a shadow on the surface of each object. The value field to the right of the checkbox sets the intensity of the shadow. Further right, the cogwheel icon offers additional parameters where we can change the direction of the light, the light shift angle, and the focus or sharpness of the shadow. But notice that only the cube casts a shadow onto other objects. If we want other meshes to cast a shadow, we need to go to the Properties Editor, choose the Object Properties page, then Viewport Display and check the Show Shadow box. We need to do this separately for each object. Cavity emphasizes ridges and valleys in a mesh by adding artificial highlights and shadows. Type determines how the cavity effect is calculated. The World option takes into account the height and depth of the ridges and valleys, while Screen does not. This means that Screen is faster but less accurate. The Both option uses both methods. The ridge and valley values adjust the visibility of the cavity effect's highlights and shadows. Notice that there are separate entries for these values for both Screen and World options. The World option has an additional settings icon where we can make further subtle changes to the effect created. If we load a different model showing a simple set of steps, we can see where the cavity effect can be of advantage. As we move to a different viewpoint, the steps can be impossible to distinguish. And although Screen cavity seems to be of little help, the more accurate World option makes the steps easily visible. Depth of field, when selected, only operates when we are viewing through the lens of the render camera. This can be used to blur out objects that are not at the focus distance of the camera. The actual depth of field details are set up in the camera's Object Data Properties page in the Properties Editor and will not be discussed in detail in this video. Outline specifies a color for the border of every object. We can click in the bar alongside to change the selected color. The same option appeared in the wireframe shading discussed earlier. Specular lighting is only available when lighting is set to studio. When activated, it adds a specular lighting effect to every mesh, giving it a slightly shiny appearance. The next viewport shading icon is Material Preview and is the first to display the materials and textures we may have added to our objects. The display makes use of the Eevee render engine to create the scene. The Adjustments panel's first entry is lighting, but the options here are quite different from that in the Solid Shading's Adjustments panel. Scene Lights uses the lights placed within our scene to determine surface highlights and shadows. The lights must be enabled in the Outliner editor. If no lights are available or this option is not selected, a default light is used. If Scene World is not selected, we are presented with a sphere wrapped in an image immediately below the checkbox. This image represents the 360 degrees background for our scene, and it is used to determine the nature of additional light falling on the scene objects. If we click on the sphere, we'll see a set of 8 images from which to choose the background image. This type of background is called a High Dynamic Range image or just HDRI. Below the selected image are various settings that relate to it. Dealing with each in a slightly different order from the listing, World Opacity defines the HDRI's level of visibility. Blur determines how in focus that image is. Strength determines the brightness of the image and hence the brightness of the light it projects onto the elements in our scene. The rotation value allows us to rotate the HDRI about the z-axis. Notice that if we change viewpoint, we can see a different part of the HDRI in the background. However, if we click on the blue globe to the left of rotation, that background image stays fixed as we shift viewpoint. This background image is for the 3D viewport window only and will not appear in the final render. If we select Scene World, then we should supply our own HDRI image. Choosing our own HDRI is done in the Properties Editor's World Properties page and is the topic for a later video. Using this approach, our background image will appear in the final render. Also, if we are using any HDRI, the Overlays panel adds a HDRI Preview checkbox. If we select this, we'll see 2 spheres in the bottom right of the 3D viewport. These show how the HDRI would affect objects with a mirror-like surface and a matte surface. Wire Color specifies the color of all the edges in a mesh and is only relevant if the wireframe option in the Overlays panel is selected. The selection and render path determines which of the many elements that go to make up the final render are to be shown in the 3D viewport. Only combined will show something approaching the final render. Compositor settings make use of an advanced topic which is not covered in these videos. There are no additional settings in this panel when we are working in edit mode. The final viewport shading icon is rendered. This will produce a similar result to the final render but from the viewpoint of the viewport camera rather than the render camera. The Adjustments panel has exactly the same options we saw previously with the Material Preview option. And again, any HDRI selected from this panel here will not appear in the final render unless it has been defined in the World Properties page of the Properties Editor. In this mode we can select between the Eevee and Cycles render engines in the Properties Editor's Render Properties page. The Cycles render engine gives more accurate results, but its use is only viable if we have an extremely fast video card, Otherwise, the time taken to re-render the scene every time we change viewpoint will be too long to be useful. This time there are no less than 13 PDF pages accompanying this video. Download them from our website.